Hello students, and welcome to this calculus video. In this video, we're going to be tackling two more problems where we're finding net and total distance. So go ahead, grab your calculators, and let's get started. All right, so the position of a particle is given by this function p of t equals e to the 2t minus 8t, where we know it's going to be measured in feet, and we want to find the net and total distance from 0.5 to 1.5 minutes. So right here, again, we want to start with the net distance. All right, so how are we going to find that? Well, in order to do that, in our previous video, we know that that's going to be the absolute value of p of 0.5 from the start to the end, essentially, minus p of 1.5. All right, so I'm going to put that into my calculator. Again, I'm going to do it the exact same way where I add a graph. And now that I have my graph up, I'm just going to go and I'm going to add a calculator value. And you can do this where go F1. We want the absolute value first, so let me grab that. So absolute value, and then we have F1 of 0.5 minus F1 of 1.5. All right, we calculate that. And again, trying to always go to 4 decimal places if you can, 3 at a minimum, 9.367. We know that this comes out to be 9.367. And what are our units of measure? And that's going to be feet. All right, so now we want to find the total distance. How are we going to find the total distance? Well, as we showed in the last video, we need to check something. We need to check to see if the velocity ever equals 0, and then we need to do some analysis around that. So what is the velocity? Well, we know that velocity is going to be equal to the derivative of our position function, which is going to be 2e to the 2t because of the chain rule, minus 8. So what I'm going to do here is, again, I'm going to come back to my calculator. Let's go back to our graph, and I'm going to want to graph that derivative. So first thing I'm going to do is I'm going to turn off our first one, and I just want to see the derivative, so that's going to be 2e to the 2x minus 8. All right, and we are looking between 0.5 and 1.5. So what I want is, I see it crossing the x-axis, and what I want to see here is, what I'm going to do is I'm going to make a sign chart that begins at 0.5 and ends at 1.5. And what I want to see is, do we have any zeros here? So we're going to go menu, analyze graph, and let's see what the 0 is. And I have a 0 at 0.69315. So I do have a 0 in this interval. That's 0.693. Okay, so left of the 0, we can see that everything left of the 0 is below the x-axis. So everything there is going to be negative, and then everything after the 0 up to 1.5 is all going to be positive. So we know that that's going to be positive there. So unlike our last video in the example that we had there, since we know that we have a change in direction at 0.693, we know that the particles' total and net distance are not going to be equal. So we do have to do that extra work. So let's find the total distance. And basically it's going to be 2 of the net distances, and we're going to cut it off at 0.693. So we're going to find the absolute value of p of 0.5 minus p of 0.693 plus the absolute value of p of 0.693 minus p of 1.5. And once we have both of those calculated, we should be able to get our total distance. So let's go back to our calculator here. And we still have, even though we turned it off in the graph, we still have our function f1. So what I'm going to do is I'm going to put in that entire expression here that I have, and I'm going to put in that entire expression into the calculator right here. So the value of p of 0.5 minus f1 minus f1 of 0.693 plus the value of f1 of 0.693 minus f1 of 1.5. All right, we get this number now And you can see, even though those distances are very close, we have 9.3 and 9.89, even though those are very close values, you notice that they're not the same. And they shouldn't be the same, right? Because we know that there is a negative distance and a positive distance here. So the direction does change. So we have from the decimal 9.894, and our unit is feet. So the total distance traveled is a little bit more than just where we ended up from the origin. All right, so let's go ahead and look at this next question, because this one is going to be the same thing, but this time we're given some trig values. So the position of a particle, we have the position, it's 2 plus 2 sine t. We know it's measured in feet, and we have minutes here. So we want to find the net and total distance. And again, let's just start with the net, because that is so simple. We just have p of pi over 6, and the absolute value of this minus p of 5 pi over 4. All right, so let me reset my calculator and we're gonna get started. I'm gonna do this the exact same way. These are meant to be done on a calculator. Sometimes you won't need a calculator or you're not allowed a calculator, but the process is going to be the same. So let's graph our function x plus 2 sine x. There we go, make sure you're in radian mode. And let's go ahead and look at the calculator. Of f1 of pi over 6, so let's go pi over 6 minus f1 of 5 pi over 4. Okay, and the decimal that we get out is 9 or 0.9892, or to 3 decimal places 0.989. And what are our units of measure? Well, we just have distance, which is just the original function, so we are going to be in feet. So now let's start with total distance. So in order to do that, we need first the derivative. So we know that the velocity is going to be the derivative of our position function, which is 1 plus 2 cosine of t. So let's go ahead and set this equal to 0. And what I noticed is I can actually calculate this pretty quickly, because we're going to get cosine of t equal -1/2. And we know that t will be equal to the inverse cosine of -1/2. And since we're only looking from pi over 6 to 5 pi over 4, we know that t, the cosine values from the unit circle, would be 2 pi over 3. Because pi over 3 would be positive. All right, so we're going to have to make a sign chart here, just like we've done in the other time. So we know that we're going from pi over 6 to 2 pi over 3, and we're gonna finish at 5 pi over 4. We wanna see, okay, what's happening in these intervals. So let's go ahead and graph our derivative. And so I'm gonna turn off our first one, just like what I've been doing before. And we're gonna graph our derivative 1 plus 2 cosine t. Okay, so we're only looking from pi over 6 to 5 pi over 4. And let me see where is 2 pi over 3, so I can kind of get a visual of this. So I'm gonna type in 2 pi over 3. All right, so that is a 0 right here, good. So that confirms the calculation that we found. And to the left of the 0, we can see that the function, the velocity function, is positive, and to the right of the 0 is all going to be negative. Now I know that it oscillates back above the x-axis, but that is going to be out of the domain that we're looking at. So we're going to pretty much ignore that part. So we know that to the left is negative and to the right, or sorry, to the left is positive and to the right it is negative. So left is positive and right is negative. And that's from analysis of the graph on the calculator. So how are we going to find total distance? Well, in order to find total distance, we got to just do what we did in the first problem of this video. So then that's going to be our position function at pi over 6 up to position function at 2 pi over 3. We want the absolute value of that. Then we're going to add in the second section of the absolute value of the position function from 2 pi over 3 minus the position function at 5 pi over 4. Absolute value of that. And let's see what we get out when we put this into the calculator. And let's see what we get out of this. 3.61652, and to 3 decimal places that is going to be 3.617, and our units of measure here would be feet. So learn these little tricks that I'm showing you guys on the calculator. Whether you have a TI Inspire or a TI 84, which is a little bit more common, no matter what calculator you have, figure out how you can use those functions from graphs and then use those in the calculations so that it's a little bit easier to make these calculations and be very comfortable using those functions there. Because in order to do that, if you're able to do that, you're going to get so much more efficient at solving these questions, because you can't just sit here typing in the functions over and over. That's going to take up way too much time on these free response questions. We have 2 more videos remaining here in this lesson where we're going to be doing free response questions. Of course, if you need help on any of these 2 problems, please reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.